a look at this example. We have this picture, and I want you to find the measures of angles 1, 2, 3, and 4 in this picture, given that lines M and N are parallel. So I'll give you a second to draw the picture in your notes before I start working it. I've given you expressions for angles 2 and 3. What do we know about angles 2 and 3? Right. Those are going to add up to 180. They're supplementary. So I can do 9x plus 9 plus 7x minus 5 equals 180. Add our like terms. Subtract our 4. Divide 16, and x is 11. Okay. I asked for the measures of all the angles. I told you one other time, the notation for measure is a lowercase m, then you can make your angle symbol. And then we're going to give the measures for 1, 2, 3, and 4. If x is 11, then angle 2, if you plug 11 in there, what do we get? 108. Angle 3 was 7x minus 5, so if you plug 8 and 11 in there, you get? How do I find the measure of angle 1? It's equal to 2. So that would be 108 degrees. How do you find angle 4? Also equal to 2. So it is also 108 degrees. Any questions about that one? Get this problem. So the measures of two angles in a triangle are 33 degrees 12 minutes and 26 degrees 15 minutes. Find the measure of the third. What do we know about triangles? They add up to 180. So how am I going to find my third angle?
Subtract both those.
Okay. You can do 180 minus each of those, or we could add them together first and then just subtract once at the end. Since it's the degrees in minutes, let's go ahead and add them together first, and then we'll just subtract. Okay, so then we add our minutes together, so that would be 27 minutes. Add your degrees. So that's 59.27. So now we have to do 180 minus that. How do we subtract those? We make this say 0 minutes and borrow. So that's 179 degrees. How many minutes carry over? 60. So 60 minus 27 would be 33 minutes. 179 minus 59 after 20 degrees. So that's our final answer. So I might give you nice pretty angle measures, or now we know degrees, minutes, and seconds. I could use those as well when we're giving measurements. All right. So far, so good. I'm going to put a problem up that I want you guys to do. So this one's pretty easy if you remember what we said about similar triangles yesterday. What does it mean to be similar? All the angles are the same. So if DEF and GHI are similar, then the measure of angle G has to be the same as D. So that's 53 degrees. The measure of angle I has to be the same as F, which is 29 degrees. Do you remember that part? Let's do an example involving their sides then. I'll give you a second if you want to draw those pictures in your notes. So we know that MNP and QSR are similar triangles. Find the lengths of the unknown sides in angle QSR. So if we just want to use our notation, since this is angle Q, this would be side Q over here. This would be side R. So we're looking for those two things. How could we find them? Okay. We know that these sides are proportional. That's what we said yesterday. So we could set up a ratio to solve this, or a proportion. What you have to do is take two sides over here. So I'm going to say R over, the only other side I know is 12, equals, and then you have to pick the corresponding sides in the other triangle. So what side corresponds to R? 10 over what corresponds to 12? Then to solve something like this, we just cross multiply. So 8R equals 120. Divide by 8, and we get 15. Okay. Now finding Q, we have to do the same thing. We're going to set up a proportion. I recommend, you know side R now, I would recommend to not use that in your proportion if you can avoid it, just in case you somehow messed up on side R. That way you don't mess up on all the others. Does that make sense? So I prefer to use numbers given in the problem if at all possible. So I'm going to say Q over 12 equals, what would my other one be? Over 8. Cross multiply. So 8Q equals 144. Divide. And you get 8. Is that okay? I'm going to put a problem up and I want you guys to try to solve it. Samir wants to know the height of a tree in a park near his home. The tree casts a 38-foot shadow at the same time as Samir, who is 63 inches tall, casts a 42-inch shadow. Find the height of the tree. So I drew the picture for you, but you could, if you don't, you just want triangles, you can redraw it. He is 63 inches. We know his shadow goes on the ground. That's 42 inches. We have a different unit here. The height of the tree we don't know. We know its shadow is 38 feet. If you change them to be the same units, that's okay. But you actually don't have to. Because both units in this picture are feet and both of them in this picture are inches, you're okay. So as long as within the same triangle you don't have different units, you can leave it as it is. So we can just set up a proportion. If you did x over 38, that would have to equal what?
63.
And there are lots of ways you might set this up. You could say x over 63 equals 38 over 42. You just have to have corresponding pieces. So if you multiply, we get 42x equals 2,394. Divide your 42 and x is 57. The height of the tree was in feet. So we get 57 feet for our answer. Any questions there? I want to do one more. I'm going to draw a picture. I want to find x in this picture. How could we do that? You can use the small triangle, that little tip up there where the height is 50 and the bottom is 100, and we could use the whole triangle where the height is x. What is the length of that entire one? 220. So we just kind of separated them. We did the little one, then we did the whole thing, and now you can set up a proportion. You could say 50 over 100 equals x over 220. Any questions about any of this?
Kind of off topic, but is the line in the middle equal to something specific? Like,
It can be, but it doesn't have to be. You could place it anywhere that you wanted. So it just kind of depends on like some of the angles that go along with it. Any other questions? Because as long as in each triangle you only have one unit, it's okay. Since both of these were inches and both of these were feet, it's okay. But if I had said like this was 150 inches, then you would have to make everything in inches. Anything else? So we've got some time now. I think it's like 15 problems, and we have 30 minutes. Also, you did pretty good, Brandon.
yeah, I don't know what's wrong.
I think we might do a quiz tomorrow over sections 1 and 2. chapter 1 only has 4 sections in it, so we're already halfway through the chapter. And I figured it would be better to do it on a Friday rather than coming back and doing it next week. So 30 minutes is probably more time than you might need for this. I might do some review problems at the end today, or maybe at the beginning of class tomorrow. We'll kind of see how much time it takes you guys on this assignment, but we'll talk about what's going to be on the quiz. It'll be a pretty short one. We haven't done that much. Okay. When would you like to take
Could I come in and